Hello. Okay. Practice problem from chapter 5. Project management practice problem. This file is on Moodle. Okay, first fill blank. This one is expected time for activity D. So expected time for D equals A plus 4 times M plus B divided by 6 equals 16 and 8, 24, and divided by 6 equals 4. And this one, variance for activity D, B minus A divided by 6 and square equals 2/6 or 1/3 square equals 0.111. So this is 4 and 0.111. And then figure out which path is critical path. There are 3 possible passes. First one, A, B, E, G. Second path, A, B, D, F, G. And the last one, A, C, F, G. So add A, B, E, G, A, 3, B, 8, E, 3, G, 4 equals 18. A is 3, B is 8, D is 4, F, G, 2 plus 4 equals 21. A, 3 plus, C is 6, plus F, 2 plus 4 equals 15. This one is the longest, so critical path is A, B, D, F, G. Question, determine the probability of completing the project longer than 24. That is, this one is expected time 21, and 24 is here and longer than, so this area. So we need boundary z score. So z equals desired completion time, asking time, 24 minus expected time, 21, divided by square root of variance on critical path. Critical path is AB, D, F, G. So add variance on critical path 0.111 plus 1 plus, why is it looks like T, plus 0.111 plus another 0.111 plus 0.444, so equals 3. Oops, it's gone. Okay. This part again. Z equals 24 minus 21, 0.111 plus 1 plus, this is 0.111 for A, B, D, F, G, 0.111 plus 0.111 plus 0.444, so equals 3 divided by square root of 1.777. That will be 2.25. So 2.25, find area from the chart. Okay, I will bring up the chart. Okay, this chart. In your lecture notes, the last page. .25 here. 2.25 is 0.98778. This one. 2.25. When z-score is 2.25, then area, the probability is 0.98778. So the area This is 21 and 24 here. On the chart, the probability given is left side. So this is 0.98778. So this side, outside or right side, it will be 1 minus 0.98778. So that will be 0.01222. So probability of completing the project longer than 24 is 1.222%. So this is the answer. So if question asked in 24, then this is the chart given probability is the answer, but this one is longer than 24. Question so far? You will take quiz number 4 next Monday. Now I will email the previous quiz number 4 now. Check your email. This problem question, what is the probability of completing the project longer than 45 days? The same as practice problem, fill blank first. So this one, expected time for F equals A 14 plus 17, 4 times 17, that is M, plus B 20 divided by 6 equals by calculation it will be 17. So this is 17. And variance for F equals B 20 minus A 14 divided by 6 square equals 6 over 6 square equals 1. 1.00. And then you need to draw network diagram using immediate predecessor and designation. A and B, they don't have immediate predecessors. So A and B starting point, eight, 6, and then C and D from A, C 11, 10, and then E from B, 11, then F from C and D, G from E, and then H from F and G. Okay, to determine which one is critical path, first, how many possible passes? A, C, F, H, A, D, F, H, then B, E, G, H, AC, 8, 11, plus 17, plus 7, 43, and ADFH, 8 plus 10 plus 17 plus 7 equal 42. B, 6 plus E, 11 plus 18 plus 7 equals 42. Longest, 43. So this is critical path, ACFH. So this one looks like 43 here and then 45 longer than. So Z-score equals 45 minus 43 square root ACFH, ACFH, 0.444, 0.444, 1, 0.444. So 0.444 is 0.444 plus 1 plus 0.444 equals 2 over square root of 2 equals 2 over 1.5 to 7 equals 1.33. From the chart, we'll bring up the chart. $1.33 here. 1.33 is between 1.3 and 1.35. 1.33 is closer to 1.35, so probably is 0.911. 1.33 up 31. This is 31, not 3. $1.31. So 1.31 is between, but closer to 1.3. So take this. So chart gives us only left side. So this one is 0.9032. So answer will be 1 minus, total 1 minus left side equals 0.0968. So answer is 9.68%. This is the answer.
I have a question.
Yes.
I just want to confirm that the early starts, early finish, late start, late finish will not be on the quiz.
You don't need. I
Okay.
will not ask finding slack. So you don't need figure out early start, early finish, late start, late finish. Don't do that.
Okay. All right, thank you. Just
It's
wanted to confirm.
wasting time. You know, like I said, you don't need to figure out early start, early finish, late start, late finish. But every time, couple of students did, so that is kind of a waste of time. Okay, so don't do that. You don't need. Just to figure out critical path using this adding activity times, and then the longest is critical path. So based on this one, find critical path, okay? Any other question? Okay.
I have a quick question.
Okay.
So if the z-score was 0.0968, then how come you didn't subtract that from 1, but you subtracted 0.9032? So wouldn't the answer be 0.9032? It's reversed.
Yes, this one, z-score is boundary. When you took statistics, you know what, standard deviation.
Yeah.
Standard deviation and z-score is the same. So on this mean, standard deviation is 0. Z-score also 0. And then z-score, if z-score is 1, then standard deviation also 1, like this. So z-score is boundary, and then how far from mean. right side is not positive, left side is negative. So first you need to find boundary, and then the area, the probability, the chart. Our textbook provide the chart, z-score, and then the probability chart, the normal distribution chart, give us only left side. So if question asks longer than that is right side, and then under the distribution, total size is 100%. So to get right side, you need 1 minus left side. So that is 0.9082. And then right side is this one, and then 9.68% is the answer. Okay, any other question? Okay, let's go to chapter. Just erase. Okay, one announcement from Student Disability Service. Please read this announcement. I will email this message. So later, if you interest in, check your email and then send your interesting to disability services at marriott.edu. I emailed the message. I'm not sure for this class how many students are disability students, but there's a student disability service emailed me and then announced 2 students in need of note taker. So if you are interested in, then email to this disability services at marriott.edu. Okay. Chapter 6. Manufacturing process. When we say process, the definition of a process, any part of an organization that takes inputs and transforms them into outputs. From this, takes inputs and transforms them into output. This part is operations. You may remember the operations definition. Take input, transform to output. So process is kind of operations, but not all process is operation. Not all operations is not process, because to be processed that are of greater value, to the organization than the original input. If a system or operations take input $100 input and then transform output is like the same value, $100. Take input and then output, transform. This is operations, but not a process. To be processed, if take $100, then output as input, then output should be greater than greater value than input, like an 150 and so on. So this is process. Another name process is like a value added, transform or value added operations and so on. So value increase, that is process. In a process, many terminologies. Cycle time, the average time between completions of successive units. If a process or operations produce items, first one take 10 minutes. Second one, 11 minutes. Third one, 12 minutes, and so on. Average time is 10 plus 11 plus 12 divided by 3 is 11 minutes. So this one is average completion time. 11 is cycle time. Utilization. In operations management, utilization is the ratio in process, the ratio of the time that a resource is actually activated relative to the time that it is available for use. So available for use, that is like a capacity, and then activated, actual activated time. Anyway, utilization in process is time ratio. If there are 10 workers, then each workers work 8 hours, then total available time, like a capacity is 80 hours. But this process or system work like only 40 hours. Then utilization is 40 divided by 80, then 0.5, 50% utilization like this. So utilization in process, time matter. How many times available, like a labor hour, machine hour, and so on. Then how many hours the machine work, that is utilization. Types of process: single stage process, multi-stage process. Single stage process, all of the activities are involved in a process using a single cycle time. start and then complete certain work, cycle time, the average completion time, cycle time, only one cycle. So all process include only one single cycle time. That is single stage process, multiple stage process, multiple groups of activities that are linked through flows. From our life example, this time because of pandemic, recently the restaurants or fast food restaurants open. So this time it is the same. If it is normal time or not. If we go like a McDonald's fast food restaurant, then when we place order, they ask if it is dine in or take out. If I say take out, so ordering process, place order and then receive my order, the ordering process, the stage done, single time, single cycle time. So if I order something for to go, that is single stage process. If I say dine in, then order process stage done. After receive, sit down and then eat. So dining, eating, another activity, start and finish. So ordering activity and eating activity, two activities linked together. That case, multiple stage process. In manufacturing, if it is engine shop, automobile company, if it is only an engine shop, so start making engine, done engine, only one activity, making engine. But engine go next stage, that can be part of a car, and so on. So only engine shop make engine, that is single stage process. But the entire automobile making a car process is multiple stage process. In process, maybe there is buffering. Buffering is a storage between stages where the output of a stage is placed prior to being used in a downstream stage. Like an engine done, and then it moved to next stage. Engine insert in the engine room and then assemble something like that. So between stages, storage area, that is buffer. This time, internet speed is fast, so not many cases of buffering. But earlier, when internet speed was not fast, then when we watch something video, then sometimes something circle like that. We call that buffering. That means before we watch, because that speed is not enough to watch smoothly, there is kind of storage area. Put that data and then a certain level and then send next like that. That is buffering. If that buffer is, there is no buffer between stages or not enough size of buffer, then two possible problems. First one is blocking problem. When the activities in a stage must stop because there is no place to deposit the item just completed. This case, if between two stages or activities, storage area is buffer. If something flow and then like this, we call it an upstream and then downstream. If capacity of two stages or activities uneven, like this one's capacity is 100 per hour. This one is 50 per hour. So every hour, 50, this one send 100, but this one can handle up to 50. So every hour, 50 pile up. Sometimes later, not enough size, or if there is no buffer, then there is no space to deposit. Then this process stop because of uneven capacity. No place to deposit. So stop. Next problem is starving problem. When the activities in a stage must stop because there is no work. The same problem when activities or stages capacity, uneven capacity, two stages or activities, and then buffer. If upstream and downstream, upstream's capacity is 50, downstream 100. If there is like an inventory, when this one send 50, this one work 100. So first time, if there is an inventory, then use some inventory. Even this one send 50, but when it's empty, then this one work 50, stop 50, work 50, stop 50, and so on. So this is starting problem. Buffer is storage area between stages. If even if stages or activities capacity is even, then no problem. But if capacity of activities are not even, then if there is no buffer or not enough buffer, then there can be problems like blocking and starving. Okay, next. Bottleneck problem. Bottleneck problem is also problem of uneven capacity of activity, like 100, 50, 100. So capacity looks like bottleneck. If there is bottleneck in a process, then uneven like this, then there is no buffer or not enough size of buffer. Stop here, stop here. Here, blocking problem. Maybe here, starting problem. So if there is bottleneck in a process, maybe blocking and starving problem occur. That is bottleneck problem in a process. Again, types of process: make to order and make to stock. Make to order only activated in response to an actual order. So don't make until customer place order. After receive customer order, start the process. That is make to order system or process. Both work in process and finished goods inventory. Anyway, inventory keep to a minimum, because don't make until customer place order. Maybe there is no part inventory, but work in process and finished product inventory minimum. And make to stock process activated to meet expected or forecast demand. Forecast future demand and then just make. Custom order are served from target stocking level. So just make and then finish product there, inventory, and then customer ask, then send the product in inventory. Hybrid process combine the features of both make to order and make to stock process or system. You know, when we go like a McDonald's, not busy time. Maybe there is no not much French fry, and then not the hamburger not make already. But busy time when we go, they just make the French fry there and so on like that. So busy time, they use make to stock system or process. Regular time, not busy time, they just wait until customer come and then place order, then start making a hamburger and so on. So that is hybrid system. So sometimes they use make to stock, sometimes they use make to order. Measuring process performance. In chapter 1 and 2, we talked about productivity, efficiency, and so on. So productivity, output over input, higher productivity, that means if there are two systems, process A and B, output is on 50 and 50 input, output and then input. B 100 using the same input. So this one is like a 2, this one is 1. So higher productivity, better process. When we determine which process is better using productivity, then higher, better. How about efficiency? You may remember efficiency is lowest possible cost using lower, making cheaper than efficiency improved. So lower cost process is high efficiency. So whichever, like the same output level, but this one use 50, this one is 100, lower, like a cost process, higher efficiency, and then that process is better process. Setup time. Setup time is kind of preparing time between different, if a process produce like a multiple product in one process, like type A, type B, and so on, then type A come and then prepare the process, type B come and then change process and so on. So setup time is kind of preparing time. Longer setup time process is not good. So shorter setup time process, better process. Runtime. The time required to produce a batch of parts. Usually, manufacturing system produce many. So usually not like one by one. Usually produce 100 by 100, batch by batch. So total time to complete or a batch, that is runtime. So runtime also, shorter runtime, better process. Operation time equals setup time plus runtime. So setup time plus runtime is like type A come and type B come, like 100 type A, 100 type B. Setup time between different types of product, like 50 minutes. And then to make one A, like 1 minute and 2 minutes. So operation time for a B equals 50 minutes plus 100 times 2 minutes equals 50 and 250 minutes. That is operation time. This is setup time. This is run time. Anyway, time, operation time, shorter, the better process. Next one, throughput time. Throughput time is kind of total time. include every time. Setup time, run time, and sometimes break time, and so on. The time that the units spent actually being worked on together with the time spent waiting in a queue. So include every time. Setup time, waiting time, break time, run time, and so on. Throughput time is total time. Process throughput time reduction to reduce, make it shorter, the total time. Perform activities in parallel. If we produce something and then many activity times sequentially, one after one, like an activity A, B, C, like this. We call this sequentially, do one after another. But if we can do parallelly, like a simultaneously, then we can reduce time like this. So if we can redesign the process, perform parallelly, then we can reduce time. Change the sequence of activities. If type A come B come, A come B come like this, then between different types of the product, we need a setup time, setup time, setup time. But if we change sequence like A, B, B, then only one setup time we need. So we can reduce time and then reduce interruptions. The cause of interruption is kind of malfunction, breakdown, and so on. So we need maintenance. To reduce interruption, we need maintenance or preventive management. So, like a prevent something unnecessary or undesired activities, like a breakdown and so on, then we can reduce time. So by those, we can reduce time, throughput time. And types of the process, project layout. You know, last week we talked about project. Project is many activities related, and then characteristic of project is a big one, like build a ship, house, building, and so on like that. So usually, the product output of project is kind of big one. So all usually fixed there, and then worker machine around the product. So product output is not moving, just the equipment move. So we call that fixed layout or process. Workstation type, when we go like a store or office, then types of this one, we go market and then aisle type process. customer A come this aisle, and then out. And then customer B may be different aisle and come out like this. So similar equipment or similar product in same area. Similar equipment or functions are grouped together. That is workstation type. Office type also, workstation type. Manufacturing cell from five minutes more from a workstation type, many different process like from workstation office type. Let's say 1, 2, 3, 4, 5, 6. Then customer A need 1 and 2. 3. Customer B need 1 and 2. 6. Customer C need 3, 4. 4, 5, 3. Customer D need 3, 4. Okay. 4, 5, 3, 4, 5, 3. D need 4, 5, 6 like this. So from a workstation type, change cellular type, cell type. So similar. This one similar, 1 and 2. This one 4, 5, 4, 5 similar, 4, 5, 4, 5. And then 3, 6, 3, 6 like this. So before using this cellular layout, cell type, 1 and 3 come 1 and 3 and come out 1 and 3, 2, 1, 2, 3, 6, 4, 5, 3 and come out 4, 5, 6 and come out like this. Because they are different activities need, so need a kind of customization. So change workstation type to cellular type, then A come, and then 3 and out. B come 1, 2, and 6 and out. C 4, 5, 3 out. 4, 5, 6 and out like this. So the path is simple, and then moving distance shorter. So if we can make workstation type process to cellular layout type, it will be better. Assembly line type. This one is straight line type, mass production system, like an automobile company and so on. Same jobs again and again. Then usually the process on line type, like here, and then activities on the line. So this one job same again and again and so on like that. So this one is assembly line type process. Continuous process. This one is similar to assembly line type, straight line type, but the flow is continuous. Like, you know, recently when we watch TV news, then you see the vaccine, the bottle move continuously, right? It's also line type, but not like this. Something flow continuously, like a bottling company and the oil company on the in the pipe, the water or oil move continuously. That is continuous type process. Okay, I think that's all for today. By the way, I said we go back to hybrid. That means including the in-class March 1st. But next week on Monday, you will take a quiz number 4. And then Wednesday is kind of the no class. So one more week online and remote only. So next Monday on the Zoom, I will see you on Zoom, not in class. And then I will announce again about when we go back to hybrid. Anyway, sorry about still making the online and remote only. Okay, if you don't have a question, see you next Monday. Don't forget to preparing the quiz number 4. And if you don't have a question, you can leave and then see you next Monday. And then if you need me, then stay. Okay, bye.
Thank you.
Thank you.
Bye.
Have a
Thank you.
good one.
Bye, thank you.